Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 29, Special Lines and Triangles. So we went from proving triangles congruent to proving rectangles, pieces, portions, whatever you want to call it, segments, diagonals, angles, sides, all that stuff, parallelograms. Now we're going back to triangles and we're working on special lines in triangles. So here's the opening exercise. So it says to construct a mid-segment. Remember what a mid-segment is? A mid-segment would be a segment that goes from the midpoint of one side of a triangle to the midpoint of another side of the triangle. It could go either way. So there could be a total of 3 mid-segments in a triangle. So we're going to construct a mid-segment. So I get my compass out. Let's change the color to red. And I'm going to put my, let me scroll up here so my compass is still on the screen. I put my compass on one of the endpoints of the sides, and then I open it more than halfway. Okay. And then I draw an arc. I don't need an entire circle. I just need an arc like so. Then I bring my compass point down to the other side, B, and I place my compass here. And let me just rotate around because I only need the intersection of this. So it crossed there and it crossed there. So that's all I need to do. Okay. So now I have this intersection of a circle with a radius that centered at A, a circle centered at A with the radius the same as this circle that's centered at B. Then I get my ruler, bring it down, and draw a segment through that. And I'm only interested in where it crosses, but I will draw it from point to point, but I'm really only interested in this location here, but I'm just showing you how that was constructed. So that goes through those 2 points right there. So there is the midpoint of AB. So I'm going to put a dot there. Okay, there's the midpoint of AB. I'm going to repeat this process. And let's draw a mid-segment from AB to AC. So now I need the midpoint of AC. So I put my compass at A. So I'm drawing a circle centered at A. I'm going to rotate it around, open it further than halfway, and draw an arc like so. Then I'm going to move my compass to C. And I'm going to draw an arc from there, making sure my 2 arcs intersect at 2 locations, which they have. So I'm done with my compass now. Now I bring my ruler over and I draw a line segment that goes from intersection to intersection. And then I draw a segment through those intersection points. So here is my midpoint of AC. So now I'm going to draw what it asked for, and that is a segment. Let's use purple. And I'm going to draw it from here to here. Okay, so there were 2 arcs to find the center of AB, 2 arcs to find the center of AC, and using a ruler, we find the midpoint. Okay, so then we draw from midpoint of AB to the midpoint of AC. So we're going to label that as it says, use your compass and straight edge to determine the midpoints of AB and AC as X and Y respectively. So respectively just means in the order of what they said. So X goes with AB and Y goes with AC. That's what respectively means. So X goes here, Y goes here. Draw mid-segment XY. So there we have it. Now if I erase all of this construction stuff, clean up my construction site. Okay, and there is mid-segment XY. It is the midpoint of AB and the midpoint of AC. XY's endpoints are the midpoints of those two sides. Now it says compare triangles AXY, the little one we just created with the mid-segment, and the original triangle ABC. Compare AYX, angle AYX. Oh, they're saying compare angle AXY and ABC and angles AYX and AYC. Without using a protractor, what would you guess is the relationship between these two pairs of angles? What are the implications of this relationship? So without using my compass, I look at this angle here and I say to myself, self, that looks like the same angle measure. And then I look at my mid-segment and I say, that looks parallel to the base of ABC. So if I have two parallel lines, think about this now, if I have two parallel lines cut by a transversal AB, then these are corresponding angles. So they must be congruent. Okay. And same goes with over here. Angle AYX is right here and angle ACB is down here. So that's these here. And again, now I have line XY parallel to line BC and transversal AYC or just AC. So two parallel lines cut by a transversal form corresponding angles that are congruent. What are the implications of this relationship? So there you have it. Okay, so if I summarize, I would say the measure of angle AXY is equal to the measure of angle ABC. The measure of angle AYX is equal to the measure of angle ACB. Segment XY is parallel to segment BC. So on page 2, we have a discussion. It says, note that though we chose to determine the mid-segment of AB and AC, we could have chosen any two sides to work with. Let us now focus on the properties associated with a mid-segment. The mid-segment of a triangle is parallel to the third side of a triangle and half the length of the third side of the triangle. That's interesting to know. So let me underline that. All right, where is it? Half the length of the third side. So let me go back. XY then, let me look at that. Let me go back to if I measure BC, that is 12.5 centimeters, 12.5 centimeters. 1/2 of 12.5 is 6.25. So if I bring this up to here, mind equals blown. 6.25. Wow. Okay, carrying on. We can prove these properties to be true. Continue to work with the figure from the opening exercise. Given XY is a mid-segment of triangle ABC, prove XY is parallel to BC and that XY is half of BC. Construct the following. In the opening exercise figure, draw triangle YGC according to the following steps. Extend XY to point G. Okay, so before I go any further, I'm going to just go and I'm going to bring that over here so I don't have to keep going flip-flopping back and forth. Okay, so here we go. So it says to construct the following. So I brought the triangle from page 1 over to here, and I took out all the assumed corresponding things, the congruencies and the parallelisms and all that. So we're just dealing with our mid-segment. It says to extend our segment XY to a point G so that YG over here somewhere is equal to XY. Okay, so I need my compass to do that. So what they're saying is you take your compass, you put it on X, open it up to Y. So basically what we're doing is we are opening our compass so we have a circle with a radius of XY. If I now move my compass to Y, and draw an arc like so, the distance from here to here will be the same as the distance from here to here. So then I get my straight edge and I put it down here on XY and I extend it. I'll use blue for this. And it goes just like so. All right, so there is my G. So let me switch to black. Let me put a dot right here, and I'm going to call that G. Okay, so far so good. So now YG is equal to XY in length. And then it says draw GC. So now I'm going to put my ruler at C, rotate it over, and draw a segment GC. So there it is. So I created another triangle, and just by looking at this, this looks like this. So it looks like it's congruent. And with doing so many proofs in the last few videos, you get really good at this and you see, oh, their vertical angles are congruent. So that's equal to that in measure. So that's an angle. And these sides are congruent because we just created them to be congruent. So that's a side. And this is the midpoint of AC. So AY is equal to CY. So these two triangles are congruent by side angle side. Wow, how cool is that? I'm probably getting ahead of myself, but this is just so exciting. Construct the following. In the opening exercise figure, we did that. Okay, what is the relationship between XY and YG? And explain why. Okay, they're equal. Why? We constructed it that way. Pretty simple, yes. Let's get that out of the way. Okay. Now it says, what is the relationship between angle AXY and angle GYC? Explain why. So I look at, now they're talking about this angle here. Let me get my pen. AXY and GYC. Wait a minute. AYX. Okay, I was going to say, what are they talking about? All right. AYX and GYC. Okay, those two angles there. Well, we already talked about that because I was just like amazed. Those are congruent because vertical angles. Okay, so they're equal. Why? Vertical angles are equal in measure. 3, what is the relationship between segment AY, and YC? That was pretty bad. Okay, AY and YC, well, this was a mid-segment, which means that Y is the midpoint of AC, so therefore AY is congruent to YC because Y is the midpoint of AC. This is pretty cool, isn't it? Yeah, it's amazing. What is the relationship between AXY and CGY? AXY and Calgary. Okay, AXY is here. CGY is right here. Okay, I think I've already said this, but let me bring it in. Okay, I made a mistake there. I labeled an angle. They're talking about a triangle. I'm not looking at my, let me get rid of that. It says triangle AXY. Okay, so keep in mind that we constructed XY and then we constructed YG to be equal in length. This was the midpoint. So as we said, it's side angle, side, side angle, side. So that is our reason here. Bring this in and we say the triangles are congruent and the explanation is side angle, side. Okay, part number 5. What is the relationship between GC and AX? So now they're asking about GC and AX. Okay, well, if we have two congruent triangles by side angle side, then corresponding parts of congruent triangles are congruent. Okay, so we would say equal because corresponding sides of congruent triangles are equal in length, or CP/CTC as we were doing in the proofs. Now it says since AX equals BX, AX is equal to BX, what other conclusions can be drawn? So now if I label that, maybe you'll see it. AX is equal to BX. Well, I see this thing here, and that is a parallelogram. Opposite sides are congruent and parallel and all kinds of stuff going on here. All right, so what's this say? Okay, so we're saying that GC is equal to BX, because if GC is equal to AX and AX is equal to BX, then GC is equal to BX by, they say substitution, but we could also use transitive property. And number 7, what is the relationship between the measures of angles AXY and YGC? So let's take a look. So angle AXY is right here. AXY and YGC is right here. Okay, so again, they are congruent. If AB is parallel to GC, if we knew that, then this was a transversal and they're alternate interior angles. Okay, but we're working the other direction. We already know these two triangles are congruent, so each angle in the correspondence to each other are going to be congruent as well. Okay, so number 7, they will be equal. Corresponding angles of congruent triangles are equal in measure. Okay, all right, next page. Number 8, based on 7, what other conclusion can be drawn about AB and GC and explain why? Now I have to go back and forth. So AB and GC, well, XG is a transversal. AB and GC have to be parallel because these are alternate interior angles to a transversal. Okay, this is pretty amazing stuff once it all comes together. So going back over to number 8, we say AB is parallel to GC. What conclusion can be drawn about BXGC based on 7 and 8? Explain why. BXGC, 4 letters. BXGC. Okay. Based on what we know now, we have these two sides are parallel because of alternate interior angles of a transversal, and they're congruent. So if they are parallel and congruent, that forces XG to be equal in length to BC and to be parallel. So therefore, it is a parallelogram. Okay, so BXGC is a parallelogram. One pair of opposite sides is equal and parallel. That forces XY to be parallel to BC and equal in length, actually. And number 10 says, based on 9, what is the relationship between XG and BC? So XG and BC. Okay, I think I just stated that, so let me bring it in as text. Okay, XG and BC equals BC. Opposite sides of parallelograms are equal. So now it says, since YG equals XY, XG equals blank XY. Explain why. Okay, so flipping back and forth here, YG equals XY. So let me look. YG equals XY. Yes, okay. Then XG is equal to what of XY? So it's saying if YG equals XY, then XY is Or xg is what? Xg is what of xy? So if xy and yg are equal in length, then xy times 2 is equal to xg. Okay, so it's 2 times. Two times xy. And the reason? Substitution. Okay, then this means BC equals what of xy? So BC equals what of xy? Well, if BC equals xg, and xg is 2 times xy, then BC is 2 times xy. So this means BC is also 2 times xy. Reason? Substitution again. So now number 13 says, or by division, xy is what of BC? Xy is what of BC? Well, it's a half. Okay, it is 1/2 BC. Note that steps 9 and 13 demonstrates our proof statements. 9 and 13 demonstrates our proof statements. 9, what conclusion can be drawn based on 7/8? It's a parallelogram. One pair of opposite sides are equal. Or by, and then it says 13, xy will be half of BC. So xy is half of BC. There, we just proved it right there. Did you see that? We just proved xy is parallel to BC and xy is 1/2 of BC. So it just said that right here. Okay. So if I get this out of the way, it said right here, prove xy is parallel to BC and xy is 1/2 of BC. So we just did all that. Okay. All right. Pretty cool stuff. I'm impressed. All right. Now let's go to exercises 1 through 4. Apply what you know about the properties of mid-segments to solve each exercise. So keep in mind that since we have just proved by doing that construction that mid-segments are 1/2 the length of the base that they're parallel to, they are also, I just said it, they're parallel and half. So apply what you know about the properties of a mid-segment and to solve the following exercise. If BC is 30 and X is the mid-segment and the mid-segment's half of the base that it's parallel to, then if that's 30, that is half of it. And what's half of 30? 15. Perimeter of triangle ABC. Well, we know that 9 makes this 9 because the mid-segment cuts one side in half. If this is 10, this is 10. So perimeter of ABC is the sum of all the distances around. 9 plus 9 is 18. 18 plus 30 is 48. 48 plus 10 is 58. 58 plus 10 is 68. The perimeter of triangle ABC is 68. Okay, so if X equals, well, this is 50 degrees and this corresponds to it, then X is also 50 degrees. So this is a really powerful exercise here that we're doing, and we just learned a whole ton of stuff about diagrams and what we can get out of them. So now it's asking what the measure of angle Y is. So here's how we do this. If this is 50 and this is 60, actually I don't even need this. Let's focus on the big triangle DEF. If this is 50 and that is 60, remember angle D, the measure of angle D plus the measure of angle E plus the measure of, what? I forgot my plus. The measure of angle D plus the measure of angle E plus the measure of angle F equals 180 degrees. That's a triangle sum theorem. And if D is Y and the measure of E is 50, and the measure of F is 60, then they add up to 180. So I combine my like terms, Y plus 110 degrees equals 180 degrees. So Y equals, subtracting 110 from both sides, Y equals 70 degrees. Okay, Wow. There is so much information we can get from diagrams if there is a mid-segment drawn. Okay, page 3 brings us to number 3, and it says in triangle RST, the midpoints of each side have been marked by points X, Y, and Z. So they did the midpoints for us, X, Y, and Z. Okay, mark the halves of each side divided by the midpoint with a congruency mark. Remember to distinguish congruency marks for each side. So what they mean by that is if that gets 1 mark, this gets 1 mark because that's the midpoint. So Rx equals XS, but we do not know that SZ equals these because we don't know that RS is equal to ST. So we have to give that 2 marks, but it is congruent to ZT. And same with over here, RY is congruent to YT. So that's congruent to that, that's congruent to that, and that is congruent to that, but not necessarily to any other side pieces. Now it says draw mid-segments XY, YZ, and XZ. Alrighty, so let me get my ruler. And I will put this right there and draw the mid-segment XY. And then I will rotate my ruler and draw XZ. Like so. And then I will draw my mid-segment ZY. Like so. Okay, let me just fix this a little bit. Okay, there we go, that's better. Okay, so XY is a mid-segment of RS and RT and so on. So there they are, all 3 are drawn. You might want to move this one a little bit. Right about there. Okay, there we have her. All right, why do we do that? A, what conclusion can you draw about the 4 triangles within RST and explain why? So if you look at this and think about all the proofs that we know now, if we have this segment, which is half of this segment, and the green one is half of RT and the blue one's half of RS, then this little triangle will be half of the RST triangle. Okay, it's going to be scaled down by 1/2. So what that means is this little triangle is equal to the big triangle. So X with Z is going to be half of RT, and I think I already said all that. So what else can we get from this? This is parallel to this, so this angle is congruent to this angle. This angle is congruent to this angle, and R is congruent to itself. So, well, that's reflexive, but I don't think that helps. Let me get that out of there. So what do we have here? We have a side, we have an angle, we have an angle. Angle, angle, side, side, angle, side, side, angle, side. But we don't know that's not congruent to that. So there's more things going on here if we keep going. This angle here is congruent to this angle here. S is congruent to YZT. All right. And then we can also say that R is congruent to ZYT. So notice I have 1 mark, 2 marks, 3 marks, 1 mark, 2 marks, 3 marks. So now I know RXY is congruent to YZT. Angle, side angle, angle, side angle. This angle here, let's see, we can go another way. If this T is to here, and this is parallel to this, this is parallel to this. So I have that and that. Yes. What else? What else? What else? I'm trying to look through here. How many arcs would this get? Parallel, parallel, transverse, or this is parallel, this is parallel. Okay. Let's see. Okay, so now one thing I wasn't thinking about was if you have a side and this is a mid segment, then this is half. So the blue line is half of RS. So the blue line is equal to XS. Okay. Same goes with this. XY is half of ST. So XY is half of SZ. So that's that. RT is twice XZ. So XZ is equal to YT. So then I put this. So let's just ignore the angle congruencies because that confuses this diagram. And if we just get it down to this, now we have four triangles with 1, 1, 1, 2, 2, 2. So 1, 2, 3, 1, 2, 3 marks, 1, 2, 3 marks, and 1, 2, 3 marks. So all four triangles are congruent by side, side, side. Okay, all four are congruent by side, side, side. State the appropriate correspondences among the four triangles with triangle RST. Okay, I've kind of already said it, so I'll just bring in the text. Okay, so all four triangles are congruent, but we want to name them in the proper order. So if we are going to be saying RST, that's RST, we went from here to here to here. Well, that would be the same as RXY, XSZ, which is right here, and YZT, which is right here. So you have to go in the proper order, but this triangle here is rotated 180 degrees. So if I say RST, then I have to say Z, Y, X, and that is right there. State the correspondence between triangle RST and any one of the four small triangles. Okay, part C. Okay, so this says RXY, RST. So all they're doing is picking one of the four from up here and comparing it to the original. So they chose RXY. You could have said YZT RST or XSZ RST or ZYX RST. Okay, so now let's move down to this question here, and it says find X. All right, so it's right here. So we're done. There's X. All right, anyhow, this is a triangle ACB. This angle's 40 degrees. This one is 61 degrees. So I can find this by the triangle sum theorem. So I can say the measure of angle A plus 40 degrees plus 61 degrees equals 180 degrees. Measure of angle A plus 101 degrees equals 180 degrees by adding these up. And then the measure of angle A equals, subtraction property of equality says that 79 degrees has to be added to 101 to get 180. So if the measure of angle A is 79 degrees and this triangle is a 180 degree rotation of the big triangle, and it's congruent, or it's not congruent, but it's half in scale factor, then the angle measures are, it's a similar triangle, so angle measures are the same. Okay, angle measures do not change, but the side lengths cut in half. So if angle A is 79 degrees, then GIH, which is where X is, rotated 180 degrees, lands on A. that must also be 79 degrees. Okay, this is the end of lesson 29. I thought this was a little bit more interesting than writing proofs, but the proofs were the necessary evil in making our lives easier when answering questions about diagrams. Go to your problem set.